Class number 3. Today, the class number 3, the previous class is the first class programming language, tokens concept, first C program, printf syntax, second class variable declarations, if else, relational logical operators, conditional operator, that discussed. Now class number 3, now the topic loop concept and scanning process. After this, you will get eligibility to start the beginning stage coding programming. Come to the loop. Purpose of loop: repetition. Whenever the code repetition is there in the picture, we need to go for loop. The required keyword while. Go with examples. Doing like this: void main body open, creating variable int I. Next, I equals to 1. Next, while. The required keyword is while. Purpose of loop: repetition. Whenever it is required to repeat the code a number of times, when it is required to execute the code a number of times, go for loop. Keyword while, parenthesis open, close, body open, printf, printf, percentage d I. Next, I equals to I plus 1, loop body close, main body close. Come to the syntax. After main, no semicolon, because it is not statement, as I mentioned before in the first class. Same like that, here also no semicolon, it is also not statement. The required syntax: while all small letters, parenthesis open close, compulsory here expression is required, condition is required. If it give like this, error, not valid. Body open, body close. This is called the loop body. Here the condition is required. Given condition like this: I less than or equal to 5, parenthesis close, brackets close. Now for this code, output is 1 2 3 4 5. Loop repeats 5 times. Check. Here, check this condition. If it is to come inside, otherwise come outside. If it is to come inside, execute everything. Once reaches end part of the loop body, go up, check the condition once again. Still it is to come inside. Go up, still it is to come inside. Go up, still it is to come inside. Like that, keep on repeat it until it is false. 1 less than equal 5 is true. Come inside, print a percentage I, so 1 printed. After that, I became 2. Reaches end part, go up. 2 less than 5, come inside, 2 printed. Next 3, next 4, next 5 printed. After that, I became 6, go up. 6 less than equal 5, false. Come outside. Reaches end part of the main body, no more statements, program terminated. Output for this code is 1 2 3 4 5. Suppose the same, in the place of while, if I give if, then output is only 1. It is not loop, don't repeat. Check the condition. Last class we discussed about if else. 1 less than 5 is to come inside, 1 printed, I became to come outside. If we give while until the condition became false, keep on repeat. Now output is 1 2 3 4 5. Suppose I'm going to swap these two. That means first increment I equals to I plus 1. After that, printf percentage I. Now output is 2 3 4 5 6. 1 less than 5 come inside, I is increased, print means 2 printed. Next 3, next 4, next 5, go up. 5 less than 5 is 2, come inside, I became 6, 6 also printed. 6 go up, 6 less than 5 falls out. Now loop repeated 5 times. Previously also 5 times, but previously output is 1 2 3 4 5. Now output is 2 3 4 5 6. Depends on our requirement. If you construct code like this, output is 2 3 4 5 6. Suppose given thing is like this, simply I given like this, then 1 printed infinite number of times. 1 less than 5 5 coming inside, 1 printed. reaches end part, go up. 1 less than 5 come inside, 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 like this one printed infinite number of times. To stop the process, control break. Program infinite times. To stop the program from the middle stage, from the keyboard, hold control key and break. Then only process steering stops. Suppose, okay. Uh, Now, a general basic confusions while we're designing the loop bodies, specifically the beginning stage. Now, I want to print the numbers 1 to 10. Required output need to be 1, 2, 3 like that up to 10. Later 10 to 1. The required output need to be 1, 2, 3 like that up to 10. So to achieve this, take a variable, start with 1, go for the loop, insert the loop, print that variable. After that, increment by 1. Here variable is increasing, so go for the condition less than or greater than, check, void main. Now the required output need to be 1 to 10. Create a variable int I. Now my required output need to be like this, 1, 2, 3 like this. The last one need to be 10. So take a variable, the variable required starting value need to be 1. Go for the loop, inside the loop, print that variable, and after that increment, and loop need to repeat 10 times. So I equals to 1, I equals to 1. Go for the loop while, leave about the condition slowly, think about the condition slowly. Inside the loop body, I written as pf, printf percentage I, print this variable and increment by 1. I equals to I plus 1. Loop body close, main body closed. The meaning of this thing is always print and increment. According to this requirement, right now this loop need to repeat 10 times. Here variable is increasing, so go for the condition less than or greater than. Suppose if I give like this, I greater than or equal to 1, run. Now output is goes on. Check. 1 greater than or equal to 1, true, come inside, 1 printed. Next to 2 greater than or equal to 1, come inside, 2 printed. 3, 4, 5, 6, 7, 8, 9, 10. 11 greater than or equal to 1, true, A, come inside, 11 printed. 12 greater than or equal to 1, true. 13, 14, 15, goes on. That means when we know that inside the loop the variable is increasing, suppose if you frame the condition like this, greater than, once it is greater than, always it is greater than only, because the variable is rising, increasing. Once it is greater than, always it is greater than only, because the variable is increasing. So when we know that inside the loop body the variable is increasing, frame the condition the style of less than. The required condition need to be I less than or equal to, like this. The required last value need to be 10. So I less than or equal to 10. The meaning of this thing is I initial value is 1 until it is smaller than or equal to 10. Keep on print and increment. Check it out. 1 less than or equal to 10, come inside 1 printed. 2 less than or equal to 10, 3, 4, 5, 6, 7, 8, 9, 10. 11 less than 10 falls out. So 1 to 10 all numbers. Now I need reverse as output. Reverse means 10, 9, 8 like this. The last one need to be 1. Here also obviously go for the loop. Loop need to repeat 10 times. Go for a variable. The variable required starting value need to be 10. Inside the loop, print that variable. After that, decrement by 1. Go ahead. Void main, create the variable int I. Next, I required initial value 10. Next, the loop while condition. Obviously, some confusions. The beginning stage, leave it. Less than or greater than, leave about that. Inside the loop body, print this variable and decrement. So printf percentage I. Next, I equals to I minus 1. Close the loop body, close the main body. The meaning of this design is always print and decrement. Here variable is decreasing, so go for the condition less than or greater than. Suppose given the condition same like this, I less than or equal to 10. Run. Now 1 less than equal to 10, come inside 1 printed. Sorry, 10. 10 less than equal to 10, true, come inside 10 printed. Next, I became 9, go up. 9 less than equal to 10, come inside 9 printed. 8 less than equal to 10. 7, 6, 5, 4, 3, 2, 1. 0 less than equal to 10, true, 0 up printed. Next, minus 1, minus 2, minus 3, minus 4. Goes on, goes on, goes on, goes on, goes on. That means when we know that inside the loop, the variable is decreasing, if you frame the condition with the style of less than, once it is true, always it is true only. So when we know that inside the loop, the variable is decreasing, frame the condition the style of greater than, I greater than or equal to the required last value 1. The meaning of this thing is I initial value is 10 until it is bigger than or equal to 1. Keep on print and decrement. Check it out. 10 greater than or equal to 1. True. Come inside. 10 printed. Next I became 9. Go up. 9 greater than or equal to 1. Yes. 9. 8. 7. 6. 5. 4. 3. 2. 1. 0 greater than or equal to 1. False out. 10 to 1. All numbers. See the basic designing process of the loop. What is specifically the confusion in the beginning stage? When we know that inside the loop the variable is increasing, just blindly go the condition the style of less than. If the variable is decreasing, frame the condition the style of greater than. That's it. Next. Okay. Now say for example I want to print even numbers up to 20. Need all even numbers up to 20. That means the required output need to be 2, 4, 6 like that up to 20. So take a variable starting value need to be 2. 2, 4, 6 like that up to 20. So take a variable start value 2. Go for the loop, insert loop, print that variable, and after that increment by 2 times. So I equals to 2. Inside the loop, print this variable printf. I written as pf. This is printf. Printf percent I equals to I plus 2. Here variable is increasing, so go for the condition less than the required last value up to 20. So I less than or equal to 20. 20. Run. Now output is 2 less than or equal to 20, come inside 2 printed. Next I became 4, go up. 4 less than 20, come inside 4 printed, 6 printed like this. The last one is 20. Okay, run this program 2 to 20 even numbers. Once again run, same output. Once again run 2 to 20. Once again run 2 to 20. Once again run 2 to 20. When we run this code n number of times, always we are getting fixed result as output. This is a scenario is called static, but application behavior need to be like dynamic, generic. That means in our regular life we are using a number of programs. Every program, specifically beginning stage, we are giving some inputs to the program. Based on the inputs, next process is going to be done, right? Go for example, go to ATM center, insert card in ATM machine. There one application will be there. When we insert card, immediately the message enter pin code, enter key. After that, on next process started. What do you want? Withdraw. Once again enter. That means at runtime giving inputs. Based on the given input, next process is going to be started. Here, this program at runtime, am I giving any input? No. When we run 2 to 20, once again run 2 to 20, once again run 2 to 20. That means right now, and these steps in that means these steps in are called static. Application behavior need to be like dynamic. Based on the given input, next process need to be start. That means we need to know that how to give inputs to the program at runtime. Generally, every application, every program, specifically beginning stage, give inputs. Not only beginning stage, maybe middle stage, final stage also, it may require. We need to know how to give inputs to the program at runtime. To give inputs to the program at runtime, go for the statement scanf. Nothing but reverse of printf is scanf. Come to the scanf syntax. Now simply I want to scan two values, display the sum of the two values. Come to the scanf syntax. Scanf, 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 void main To scan two values right now. So take two variables, any name. Okay, I taken the names like this, A, B. Now two variables are there. The names are A and B. The initial values of A and B, garbage, as I mentioned in the last class, some junk values. Before scan the data, always go for a meaningful message, output message, like enter two values or enter two integers, enter two numbers, like that. No message, blank screen. When we insert card in ATM machine, message na enter pin code, something like that. No message, lot confusions will be there. Kada. So message printf written as pf, printf, one message enter two values or two integers or two numbers. What message we feel comfort, go for that message. Next, go for the scanf statement. SCANF, scanf, percent D, ampersand A, comma, ampersand B. Next, on to print the sum of these two. Printf slash n percent D plus percent D equals to percent D A, comma, B, comma, A plus B. Close. Okay. Run. Assume that this is the output screen. When we run it, the message on screen, first enter two values, and cursor is blinking. Assume that this is output screen. Cursor is blinking there for the two values. Scan of percent. Percent stands for integer, as I mentioned before in the previous class, the format space for integer. The meaning of this thing is simply take two integers. Scanf syntax almost same as printf syntax, but here the ampersand symbol required. The meaning of this thing is take two integers from the keyboard, place the first value to this variable, second value to this variable. I'm going to enter like 10, 20, enter key. 10, 20, enter key. Now the value of A became 10, B became 20. Next printf slash n. Slash n stands for next line. Come to the next line. Printf percent D. The value of A is printed here, nothing but 10 plus symbol. The value of B printed here, nothing but 20. Next equal to symbol, nothing but A plus B, nothing but 30. That means based on the given input, output came. Like this, whenever it is required to give inputs to the program, you can give like this. Here come to the syntax. The scanf syntax almost same as printf, but here this ampersand symbol is required. Why this ampersand symbol is required? Leave it right now. To analyze the purpose of this ampersand, you need to know n number of another concepts, what we're going to discuss later coming classes. Functions concept, pointers concept, addresses concept. After completion of those all only, you will get eligibility to analyze what is the exact meaning of the ampersand and what is the purpose of the ampersand. At this stage, the beginning stage, think that simply it is a syntax, just give like that only. Future, we're going to discuss about the purpose of this later. After completion of functions, pointers, we're going to come back. We're going to debate the purpose of this ampersand symbol. Okay, fine. Suppose here the generalized mistake done by everyone. Suppose there is no ampersand symbol. Given thing like this. Can we run this program? Is it valid? Yes, we can run. Be careful. C is not that so friendly compiler. That means right now we are not getting any error. Error is coming so comfort. Error is coming means someone is telling the mistake here. Error is coming means compiler is telling the mistake. No error, then only complexity is going to be increased. These type of scenarios, say for example, another popular programming language like Java, error is coming so smart. Java is so comfortable to the developer to develop a program. To develop a program, C and Java, which is more comfortable programming language? Java, not C. Intention of Java is different, C is different. Java is very close to the developer, programmer. C is very close to the system. C is rocket speed, high speed. We can't compare the C performance with any another programming language. If everywhere the checkings are going to be done, if the when we submitted code to the compiler is going to read the code. That is called compilation process. If anything is not understandable, the compiler is throwing error on screen. What is this? I'm not getting it. Nothing but that is called error. C compiler, it is not going to take 100% responsibility to check that correct, this correct, this correct. Only essential errors only it is going to be checked. If everything is going to be checked by the compiler, obviously the process becomes slow. So the great person Dennis Ritchie who developed this programming language, these type of responsibilities must take care by us. Here right now there is no error. Be careful, no error, then only complexity is going to be increased. Here right now no error. No error, then debugging is difficult. Fix the issue will be difficult. Here input functionality is going to be collapsed. That means here previous value is not going to be modified. You can run, enter two values, 10, 20, enter key. Then output will be some garbage plus 20 equal to garbage. A previous value not going to be modified. Initial phase garbage. Garbage will be there as it is. So garbage plus 20 equal to some garbage. That means we entered something, but next process going to be done with some another values. Be careful with this ampersand symbol. Okay. Come to this program. Here right now, this is the program is giving always even numbers up to 20. Now a small modification. I need even numbers up to the given number. So to achieve that, take one more variable, scan at runtime, I comma n, message, printf, enter number. Next, scanf, %d, ampersand n. Next, I equal to 2. In the place of less than or equal to less than or equal to n. Now it is dynamic. Previously static, 2 to 20, 2 to 20, 2 to 20 always. Now this is the program is giving always even numbers up to the given number. That is going to confirm at runtime. At runtime, message enter number. Suppose I'm going to enter 30 up to 30 even numbers. If you enter 40 up to 40, that's it. This is the syntax about Scanf and the loop. First class, arithmetic operators, tokens concept, first C program, printf syntax. Second class, variable declarations, true false concept, relational logical operators, if else, conditional operator. Third class, this class, loop syntax, scanning process. These are all the basic essential things you need to know to construct at least one small program meaningfully logical. Now you all are eligible to start the beginning stage coding, the beginning stage programming. Okay, now go with some programs. And